Okay. So in this class, we are going to discuss about second order differential equation with the constant coefficient. Okay. So otherwise, we can say simply higher order. So higher order linear differential equation with the constant coefficient. Higher order linear differential equation with the constant coefficient. So first we discuss second order. Okay, because in the examination they ask the second order only. So suppose you find the if you take the second order differential equation with the constant coefficient. So any general second order linear differential equation with the constant coefficient is of the form. So what is the form? So the general second order linear differential equation, simply we can say y double dash plus a times a y double dash plus b y dash plus c times y equal to some function of x. Maybe we can call some r of x. So where this a, b, c are constant, where a, b, c are constants, and a should be non-zero. Otherwise, it should be first order. Okay, and this r of x is any function. It's a continuous function already. So r of x is a continuous function. Continuous function. Now, you have to find the solution of this equation. Maybe we call the equation is 1. So our aim is to find the solution of this differential equation. So the solution contains two parts. Maybe we call the solution is y, contains two parts. One is the complementary function. Another part is particular integral, PA. So what is CF? The complementary function. So how to find the complementary function? So complementary function. So any solution of the second order differential equation, even if you take a variable coefficient or constant coefficient, it contains two parts. One is complementary function, another one is particular integral. So simply we can call CF, complementary function. So complementary function is nothing but just the solution of the so given equation is non-homogeneous, okay, because in the right hand side we have a function r of x. Suppose right hand side we have 0, such an equation is called a homogeneous equation. So the solution of the homogeneous equation is called a complementary function. So the solution of if you find the homogeneous, that is y double dash plus a times y dash plus b times y plus c times y equal to 0. If you consider this homogeneous equation and then find the solution, such a solution is called a complementary function. So it's called complementary function. It's called a complementary function. Now the particular solution is nothing but if you have to find the particular solution of the given equation. But now question is how to find the solution of this homogeneous equation. That is the first step. Now first we have to find that what is the auxiliary equation. So given any equation we can write auxiliary equation. So what is the auxiliary equation? If you replace y by m, y dash by m square, y double dash by m double square. Okay, therefore we get a m square plus b times m plus c equal to 0. So this is a Euler equation. Sorry, auxiliary equation. How we'll get this one? You have to take dy by dx is m. Therefore, d square by dx square is m square. Okay. So therefore, the auxiliary equation of this equation is a m square plus b m plus c equal to 0. Now, this is a quadratic polynomial in M. So therefore, it have two roots. So any quadratic polynomial, we know the formula. So therefore, it have two roots. So based on the nature of the roots, we can write the solution of the equation. That is a complementary function. So what are the nature of the solution? Because we have two roots, namely we call M1, M2. And depending upon the nature of M1, M2, we have corresponding to the complementary function. Maybe you can make as a table. Now assume that these have two roots. We assume that M1, M2 are the roots. M1, M2 are roots of this auxiliary equation. Now we have a nature of this equation and then complementary function. So the complementary function and the nature of roots. Nature of roots of the auxiliary equation. I simply say A, auxiliary equation. So the first one is, suppose the roots M1, M2 both are real and distinct. Both the numbers are real and distinct. In that case, what is the complementary function? Y equal to C1 times e power M1x plus some constant C2 times C1, C2 are constant e power M2x, where M1, M2 are real and distinct. Okay, this is the first case. Now, second case, suppose both real and equal. So in that case, what is the complementary function is y equal to C1 plus C2 times x power e power. Suppose this M1 equal to M2, we call the common name is M. Okay, therefore, it's nothing but Mx. Both the roots are equal and real, then the complementary function is y as C1 plus C2 times x into e power Mx. Now, the third case is both are complex number or the imaginary number. Suppose imaginary roots. And we know that whenever a plus ib is a root, then suppose alpha plus I beta is a root, then alpha minus I beta is also a root of a polynomial. We know that, right? Because complex roots are appear in pair. So in this case, that is M1 equal to alpha plus I beta, M2 is alpha minus I beta. In this case, the complementary function is e power alpha x, the real part of this number, times C1 cos beta x plus I sin beta x. This beta is the imaginary part of the root. So this is a case. So if you take, so this is a method to find the solution of this homogeneous equation with the constant coefficient. That solution is called the complementary function. So the next thing is we have to find the particular integral. Anyway, first we solve some problems. Exercise. Solve d square y by dx square minus 3 times dy by dx plus 2y equal to 0. So this is a given equation. We have to find the solution. So the auxiliary equation is, what is that? M square minus 3 times m plus 2 equal to 0. Now, if you simplify this, you will get 1 and 2 are the root, that is m minus 1 into m minus 2 equal to 0. Therefore, the roots are m equal to 1 and 2. Since the roots are real and distinct, therefore, the complementary function is C1 times e power 1 times x plus C2 times e power 2x. Okay, this is a solution in a complementary function. Look at another example. Solve. Either they can use the notation d square y by dx square or something, or simply use the capital D. Okay, so d square plus 6 times d plus 9 equal to 0 or to y into y, okay, equal to 0. So where what is d? D is nothing but the derivative of x, derivative operator with respect to x. Either you can use this notation or this notation. Now, what is the solution? Again, you try the auxiliary equation. So the auxiliary equation is m square plus 6m plus 9 equal to 0. Okay. So this is nothing but actually m plus 3 whole square equal to 0. So therefore the roots are minus 3. Repeated 2 times. Minus 3 is the root. Since the roots are real and equal, therefore the complementary function CF is C1 plus C2 times x times the common number e power minus 3x. Okay, this is a solution. Or you can take y, because here there is no r of x, therefore directly we can write y. Okay. Now the next thing is we have to find the particular integral of a second order differential equation with a constant coefficient. So the next is methods of finding. So there are some methods. Methods of finding particular integral. Simply say PI, particular integral. So what are the methods? So the first one is type 1. So type 1 is depending upon the right hand side function r of x. Okay. Suppose in the equation, if the right hand side function r of x is the exponential function some e power some thing, maybe you can take already we go, maybe we can rx, it's not issue. Okay. So the right hand side is the exponential function, and there are two cases. Case 1. So actually the given equation we can write is of the form f of d. It's a function of d into y equal to r of x. What is the given equation? Maybe is of the form a times d square plus b times d plus c into y, right, equal to r of x. This is a given second order equation. Now we call this is f of d. Therefore, what is y? R of x by f of d. That is a particular integral. Now there are case. So if substitute replace d by r, that is if f of r is nothing but the coefficient of this one. So maybe we get maybe confused. We can use some other notation. Some l into x. Now first you have to find what is f of l. If f of l is non-zero, then you can directly write that if f of l is non-zero, then the particular integral is just to 1 by f of l into e power lx, l into x. The first case. Now second case, suppose f of l is 0. If f of l is 0, so that means what? L is a root of that function f of d. Suppose is repeated r times, then the particular integral. So see, therefore L is a root. Therefore d minus L is a factor of f of d. Okay, f of d can be written as it contains the factor d minus L into something, some pi of d. Suppose L is a root repeated r times or sometimes some t times. Then what is the particular integral? Is x power r by r factorial. times e power ax, e power lx, but there is no pi of t. Suppose exactly we can write f of d is t minus l into this power e power t, then not this one, x power t. How many times it will be there? T times. Therefore, x power t by t factorial times e power ax. Sorry, e power lx. E power lx. So this is a particular integral for this case. Now we solve some problem. There are so many cases there. We will discuss one by one. So now exercise. Suppose the right hand side function is some exponential function. Okay. So find or solve d square plus some 7 times d plus 12 times y equal to e power 2x. Now first you have to find the complementary function. Okay, for that we have, what is the auxiliary equation? The auxiliary equation is m square plus 7 times m plus 12 equal to 0. Now if you solve this, we can 4 and 3 are the root. Therefore m plus 3 into m plus 4 equal to 0, because this is a root. Therefore the roots are minus 3 minus 4. Since the roots are real and distinct, therefore the complementary function is some c1 times e power minus 3x plus some c2 times e power minus 4x. So next you have to find the particular integral. So the particular integral PA is, first what is f of d? F of d is the given function d square 7d plus 12. Now here L is 2. So what is f of 2? If substitute x equal to 2, we get 2 square is 4 plus 2 into 7 is 14 plus 2, that is 30. So that is a non-zero number. Therefore, we can directly write the particular integral is 1 by 30 times e power 2x. Okay, this is a particular. Therefore, the solution is y is complementary function plus particular integral. So complementary function is c1 e power minus 3x plus c2 e power minus 4x plus 1 by 30 e power 2x. Okay, so this is a solution. Now, type 2. Suppose the right hand side is a trigonometry function, either sine or cos. Type 2. Suppose the right hand function, if the right hand side function r of x is either sine some lx or cos lx or cos of some lx. Okay, L is some number. Now in that case, what is the particular integral? So again, case 1. So if you have to replace d square by minus L. Sorry, you have to minus a square. So the given function can be viewed as a function of d square. Okay, so that is f of d square. You can see d square by minus a square. If it is non-zero, then the particular integral is. So if f of minus a square, so that means just replace d by minus a square, not for other numbers, only for d square. Suppose this is non-zero, then the particular integral is 1 by f of minus a square times, suppose if you take a sine case, okay, sine of Lx is the right hand side, into sine, okay, not a square, sorry, L square. Into sine Lx is the particular integral. Similarly for cos, again, similarly, again if f of minus L square is non-zero, then the particular integral is 1 by f of minus L square times cos of Lx. This is the first case. If it's equal to 0, then what is the case? So case 2, suppose if f of minus L square is 0. So in that case, so therefore it contains a factor 1 by d square plus L square. So there are, therefore, if 1 by d square plus L square, because if you replace d square by minus L square, we get 0, right? Suppose this is a case, then this is nothing but minus x by 2L into, you have to differentiate sine. What is the definition of sine? Cos of Lx. Okay, so similarly for 1 by d square plus L square times cos of Lx is, if it is 0, then again this is x by 2. That is, you got to integrate cos, not differentiate. If you integrate cos, we get sine Lx by L, but is 2 times L, x by, okay. So this is the thing. Now we solve some problem related to this. Right hand side is a trigonometric function sine or cos. So solve exercise. Solve d square minus 2d plus 1 times y equal to cos 3x. So as usually you have to find the complementary function. So therefore auxiliary equation is m square minus 2m plus 1 equal to 0. So this is nothing but m minus 1 whole square equal to 0. Therefore m equal to 1 is there 1 comma 1 another root. Since the roots are real and equal, therefore the complementary function is sum c1 plus c2 times x times e power x. This is a complementary function. Now what is f of d square? The given function is d square minus 2d plus 1. Now L is here 3. Now what is f of minus 3 square? That is minus 9. You substitute d square by minus 9, we get minus 9. And what? Minus 2d plus 1. So anyway, it will not 0, right? So therefore, what is the particular integral is 1 by f of d square. So it's nothing but, if you simplify this, we get minus 8 minus 2d into cos of 3x. So if you can take minus outside, or you can take minus 2, minus 1 by 2 outside. Otherwise, if you take minus 2 outside, you get a d plus 8 into cos of 3x. You got multiply and divided by d minus 8 by d minus 8. Therefore, in the numerator, we have d minus 8. The denominator already 2 into d plus 8. To multiply that d minus 8 into cos of 3x. Now the denominator a plus b into a minus b format, therefore a square minus b square. So therefore it's minus d minus 8 by 2 into d square. 8 square is 64, right? or I did, oh, sorry, I already we take 2 outside, therefore should be d plus, sorry, we already take 2 outside, therefore should be 4. Therefore, this is 60 into cos of 3 a square. Now replace d square by minus 9 again, because we have a d square in the denominator. Again, you got to substitute d square by minus 9. So minus 9 minus 16 is minus 25 is not 0. So minus minus already minus here. So therefore plus thing, and then 50. So 1 by 2 into 25, that is 50. And then the numerator we have d minus 4 times cos of 3x. Now d is nothing but the derivative operator. Therefore 1 by 50 times, we differentiate cos 3x, we get minus sin 3x. If we differentiate 3x, we get 3. And then minus 4 times cos 3x. So this is a particular integral. Therefore, if you sum these two, you will get 3. Otherwise, if you want, you can take minus outside from the both things, you get minus 1 by 50 times this. Anyway, therefore, the solution is complementary function plus particular integral. Okay. Now, another thing. Suppose the right hand side is the polynomial, that is in terms of x. So the next type 3. So the right hand side function r of x is, so if the r of x is some x power m. Okay, m is any positive integer. Then what is integrating factor? So first you have to expand, because y is nothing but 1 by f of t times x power m. Okay, we can simplify this into this form. Now we have to expand this. So expand 1 by f of d in a, first you have to expand this f of d into a decreasing order or ascending order. Ascending powers of d as far as t power m, and operate on x power m to the each term. So d is nothing but just derivative. So d power n means what? We have to differentiate m times. Now we solve some problem. Exercise. Solve d square plus 3 times d plus 2 into y equal to x square. So the right hand side is a polynomial. Now the same way you got to find the complementary function. Therefore the auxiliary equation is m square plus 3m plus 2 equal to 0. So this is sum of the roots, product of the roots. Therefore you will get m plus 1 into m plus 2 equal to 0. Therefore m equal to minus 1 minus 2 are the roots. Since the roots are real and distinct, therefore the complementary function is c1 times e power minus x plus c2 times e power minus 2x. Now the particular integral. So the particular integral is 1 by f of d into x square. But what is f of d is d square plus 3d plus 2 into x square. So first you have to write in the ascending order, descending order. First I write 2 plus 3d plus d square into x square. Now we can take 2 outside from the denominator. So therefore this is equal to 1 by, if you take 2 outside, we get 1 plus something. The something is 3d plus d square whole divided by 2 into x square. Now you take this term to the numerator, we get minus inverse. So therefore 1 by 2 times 1 plus 3d plus d square by 2 whole power minus 1 into x square. And we know the formula 1 plus x power minus 1 formula is alternatively plus and minus 1 minus x plus x square plus x minus x cube plus x power 4 and so on. So using this formula, we can expand this. Therefore, this is equal to 1 by 2 times 1 minus what is x? This term 3d plus d square by 2. This 1 minus x plus x square, that is 3d plus d square by 2 whole square minus and so on. It's a series into x square. But what is the derivative of x square is 2x. Again, what is the derivative of, if you take again, if you differentiate, we get 2. If you take third time derivative, we get 0. So therefore, we can take only up to second derivative, because so third derivative, after third derivative, everything is 0. So if you expand this 1 by 2 times 1 minus, if you multiply minus inside, therefore 1 by 3d by 2, 1 minus the 3d by 2 minus d square by 2, plus if we expand this, this is actually 1 by 4 outside, and a square, that is 9d square plus 2ab plus b square, right? So even if you take in the next term, you have a cube. Therefore, all the terms contains a derivative of 3. So d cube. Therefore, it must be 0. Therefore, no need to write all other terms into x square. Now multiply, operate x square each term. Therefore, 1 by 2 times 1 into x square is x square minus 3 by 2 times derivative of x square is 2 times x minus 1 by 2 times what is the second derivative of 2x is 2 plus 1 by 4 times 9 into what is the second derivative is 2, 9 into 2 plus the third derivative is 0. Therefore, 6 into 0 is 0. 4 derivative is also 0. Okay. Now, finally simplify. 1 by 2 times x square minus 2 to cancel, we have 3x. 2 to cancel, we have 1. This is nothing but you can cancel this. Therefore, we get 9 by 2. So, 9 by 2 minus 1 is 7 by 2. Therefore, 1 by 2 times x square minus 3x plus 7 by 2. So, this is a particular integral. Therefore, solution is equal to complementary function plus particular integral. Okay, this is a general formula. So, if the right hand side is a polynomial exponential function x power m, then the f of d can be written in the decreasing order. Anyway, we have to modify into 1 plus something, 1 plus x format, and then take that to the numerator, and then using the formula, and then expand it, and then multiply x square each term, and then find the answer. Okay. Now, these are all 3 basic function the right hand side. Suppose the right hand side is the combination of this thing. For example, e power ax into sine or e power ax into cos. So in that case, how to find the solution? And we will discuss that in the next class. Okay, I can stop.